We have overall lines that I told you about, that's happening next month. We have copy and code at North American University. I'm not sure if it's currently running right now, but if you follow our meetup group, you can find out more about that. That's more for like university students, but we encourage everyone to kind of come out. And we also have Pizza and Code. That's the original one. That's over improving your city center. And then finally, we have Code for All Kids. This is something that we found need for. We saw one of our community members bring one of their sons with them, and we're like, hey, why don't we make a Code for All Kids for those kids that don't want to learn technology? So Nargiza, our president, she's the lead organizer for that. So I'm excited about that. But like I said, if you guys want to join Code for All, we're all volunteer based. I don't get paid for this. I do this because I love the community, and I want you guys to join. Right? Coding, and then he got into Java and tech. And then he said, hey, that's not enough challenge for me. Now he's getting paid by the UN to go to.
Oh, yeah, it's just limited resource environment.
So now the UN flies into limited resource countries to teach technology to kids. So very grateful. It's good that he's in the United States for him to speak, but welcome Henry Lee.
Thank you, William. Thank you guys to Sparks for hosting these excellent talk here. So let me just get this set up. By the way, I'm a little bit curious right now. Like, who here is actually like works in programming or is kind of technical or does code? Well, I just want to set the expectation that basically what's going to be happening for this type of course right here is we're just going to go over a lot of the fundamentals. Like, wanted this to be specifically built for beginners, so we just talk about what exactly is AI, how does AI actually work, why would you want to use it, and we're going to talk a little bit of the technicalities of how it does function. So, anyway, I will go quickly about who I am, what we do, and then we will talk about the introduction to AI. So, my name is Henry. I created this organization called learnanywhere.org. I started as a software engineer, but I always consider myself more as a teacher. Okay. And so what I did is I worked for Free Code Camp, made tons of different types of coding tutorials from different things like full stack development. Oops, I think I have this stand here. Full stack development type of topics, or sometimes like REST APIs to machine learning. And now I basically go out to different countries where I talk about AI literacy. And so the organization I work for is called learnanywhere.org. And basically what we do is we just build free mobile-friendly, offline-first AI literacy curriculums for these low-tech environments. And quickly, this is just some of the kids that we work with that use some of our curriculums and content from different countries. This is also project-based, so we also have kids basically working on the projects. This is the team, and we actually do have one of my teammates here is James. So if you guys can clap for my buddy James. He's one that contributes a lot of the AI materials that we basically create. Oh yeah, there's James, first of all, using content at the moment. So anyway, we're going straight to talking a little bit of an introduction to AI. And like I said, this is not going to be very heavy on the programming side. I basically took out the coding aspect, so we're just going to go over mostly the fundamentals and just kind of getting started from scratch. So talking about AI literacy. So, this is going to be very hands-on, where basically what's going to be happening is anytime you see a book at that corner, it's basically a lesson that I'm going to be teaching. If you see a person running, it's going to be an activity that we're all going to do. And if you see a little cloud over there, that's basically a chance to have reflection and to share your own stuff with us. I also am happy when people participate, but I also do something called the popcorn method, which means I just randomly throw this ball at somebody, and they're going to be answering the questions there. And if, for example, if I throw the ball to you, you're free to throw it to somebody else to answer the question. Okay? Just make sure that everyone's awake. All right, let's get started with this. So, we're going to talk about what exactly is artificial intelligence. And the first question I want to ask you guys is, what do you guys think makes a human intelligent? Think about that for a few seconds.
Yeah, compared to what?
It's whatever you guys want to do. It's anything you want to say.
No, I know this is repeating a sentence.
I'm going to just randomly, so just take a few seconds to think about it. And I'm just gonna randomly throw this to somebody to just get some insights. You guys can talk to each other, by the way. You guys are like looking at each other like you guys are network. You guys are trying to network too, so just talk to your friends and be like, what do you guys think makes human intelligent? All right, let's go.
Brain power.
Brain power, yeah, that's a good one. Throw it to another person.
Or help me.
Reasoning. And let's try to get one more person. Oh, I like that with logic. It's like, oh no, you can keep that by the way. You're gonna yeah, okay, look, I understand. Intelligence is a very hard thing to really define, right? But you know, the way of how we can kind of break it down, and when we look into the field of AI, is we can look at it in terms of two features: autonomy and adaptivity. When I say autonomy, I just basically mean that we can make decisions on our own and to act independently. And when I say adaptivity, we can learn from our experience and actually improve over time. And so basically, a bunch of curious people, they came together, they were wondering, how can we simulate this human intelligence into machine? And that's where artificial intelligence came to be. A field of study where we basically create systems and machines that can simulate human intelligence. So I think a lot of you guys kind of already know some examples of AI. You know, self-driving cars, for example, ChatGPT, human robots. But even if you do something as simple as getting text messages or recommendations from your social media, that is basically, you know, a type of artificial intelligence that you engage with. So what makes something AI is, again, that feature that kind of makes humans intelligence is this autonomy, which is it can make decisions or predictions on its own without human guidance every step. And adaptivity, it's able to improve its performance over time as it gets more data. Okay, so like self-driving cars, for example, it can make decisions on its own, and it's adaptive because essentially it will collect data over time, which we will later use to improve its performance. So, my next question, and this is more for me to kind of feel the room a little bit, is how do you guys think AI is changing the way we do things in our daily lives? Give me anything. There's no right answer to this.
Increasing your productivity.
Ooh, throw that. That's that guy. Where? Okay. Ooh, nice catch.
Throw it back.
No. What'd you say?
Increasing your productivity and efficiency.
Increasing productivity. Nice. Throw it to that person. Is that guy good? Oh my god. It's like
It's you, sir.
I dropped it in a while. I think generally, especially the more complex model everyone's talking about now, is great for compiling and summarizing a lot of information at once, resolving to get through huge tasks into breaking those smaller tasks.
that makes a lot of sense. Yeah, I forgot we kind of all squished together, so. It's okay, you can answer your question.
I think the AI is making us stupid.
Yes, I agree. It's your response, by the way. Throw that to another person and get it
Anybody
wrong.
else?
So,
Well,
by the way, I actually do. Oh, I've always tried this guy as well, too.
Quickly onboard us to new domain knowledge.
New domain knowledge.
What's the main knowledge?
For example, like I'm normally JavaScript, but I was trying to do something in assembly, and it quickly wrote some working assembly code for me that got me immediately started doing it.
Yeah, that's great.
And immediately, so I can do x86 assembly, pick it up in basically 1 day.
Yeah, that's great. Yeah, you keep that, by the way. We're going to go for another interview. And by the way, I appreciate you talking about the cons of it as well, too. Because sometimes people are like, it makes it lazy as well, too. So.
yeah.
You know, so what I heard from this is that there's tons of pros and there's cons to this type of tool. It can definitely make us more productive. But for a lot of people, it can also make us a little bit lazier, too, right? We do too much cognitive offloading for it. And so it kind of just goes to this idea that they're really, okay, so I know there's maybe some people that are AGI people around here. I don't know. We can talk about that later. But as of now, where the direction is going for technology, it's really just fundamentally a tool. And with any tool, right, there's always personalize your experience. But also be very negative, where they can make very wrong predictions. It can basically be treating other people unfairly, and it can be used in very harmful ways as well too. So, I'm just going to talk about the positive impacts, but basically right here, what we have here is, this is just a case in Africa, but one of the apps that we use down here is something called Plant Village Neighborhood, which is a very simple app where farmers can essentially take pictures of plant leaves and decide whether or not it is sick or not. And it really helps a lot in making sure that the plants are growing strong and healthy and providing food for people around the area. And so, the way how it does it, analyzes tons of images, over 60,000, and specifically for 39 plant leaves inside there. And so what it does is it's basically recognizing tons of patterns in each image, but sometimes, as you guys can see, it can be very wrong as well too. I mean, this is definitely not a peach. This was basically a grass I just took a picture of, and you can see that it classified this as a peach, and the reason for that is because it has never seen a grass before. So basically just kind of connect something that it basically knows from its data set. So what's going to be happening in this session is you guys are essentially going to be going around the area, maybe outside. Are we paying people going outside, by the way? Or is it no? Okay, cool. So there's going to be a little app that you guys are going to be using, that these kids do, where you're going to be taking pictures of various items, and you're going to be building your own image classifier, whether that's going to be plants, whether that's going to be different materials, whether it's sign language. It's up to you guys what you want to do. Everyone here has their phone, by the way, right? Okay, cool. All right. So jumping to lesson number 2 right here, so we can get started with this. So the way how a student typically prepares for exams, and maybe this is oversimplified, is they take their notes and they study their notes, and they basically have a smarter brain. And the process actually kind of works quite similar to how machine learning works as well too. Because what we see over here is that machine learning, we basically give computers just these sets of instructions to let them find patterns in that data to make predictions. And so basically, similarly to Plant Village Neighborhood, we give tons of different types of images. We get a time to basically analyze the patterns, and as a result, we have a predictive plant health disease app. So really, the key parts of machine learning that you're going to hear tons of all the time is basically models, data, and training. Model is just simply the program that captures the pattern to use to make those predictions. The data is just simply what we input into that model. And the training is just the process of the program trying to find patterns inside those data. And the training model is just simply the result of all of those 3 things combined. So, enough of me talking. I know I've been talking a lot. I've been trying to be quick for that. What we're going to start doing now is we're going to be creating a model using an offline image classifier. And so, at the moment, you guys are just going to access it on the website. But basically, how it works is right here. So these are just some student examples. Some kids went around their surroundings. They took pictures of different types of plant leaves to build a plant classifier. Some kids went around and took various pictures of materials around the area, sometimes trash. Whatever you guys want to do. And some kids are very creative, where they decide to do sign language as well too, while having these materials. So it's really up to you guys. And so the way I use this image classifier, right, is basically you guys, I'm going to be here, me and James are going to help you kind of get you guys set up. Whenever you have questions, you guys are free to go around this parameter. So step number 1 is you're going to create your project. You're going to create a name for that project. And then step number 2 is where you're going to start defining your group. So what exactly are you trying to classify? So if I'm trying to classify between like rocks and leaves, right, I'll create a group like rocks, and I'll create other groups like leaves, and have individual pictures. So in this case, I have a group for plastic cups, and I have another group for glass cups inside there. And then what you're going to do is you're going to use your camera app to just take pictures of the items, and you're just going to put inside the group inside here, which is the first part, which is data. Then you're going to be doing the training. We're going to be talking about training in the next lesson, but essentially what you're going to be doing is you just go to the training tab, click train model, and it's basically going to do all the analyzing of the data that you have in that data. And then finally, you have your model that you can test where you're going to essentially just take a new picture of something random, and you're going to see if it's going to classify it correctly, which in this case, it calls it a plastic. So, before you guys get started, I want to let you guys know that this thing, like what's obvious to you guys is not going to be obvious to the machine, right? I'll let you guys figure that out yourself. But basically, you need to give it tons of examples for it to be able to kind of distinguish the items you get. Because if you guys do finish the models early, I'm going to be testing it and seeing if it actually does work. Okay? So anyway, this is the app. You can start exploring your environments. If you guys have a QR code, you can start scanning. And me and James, so James and I will help you around, and you guys are free to go anywhere you guys want, I guess. Upstairs is off limits, right? I'm guessing. Oh, you guys are still sitting? You guys want to sit down? You guys want to move? You guys want to take pictures of your cups and tacos? By the way, this is actually being used offline, so it's the environment. All right, so here's
capture these like?
Yeah, that could be it. Yeah. Maybe it looked at you and it got confused. Yeah. Yeah, what's up?
I had one that I did the model on in this class.
Yeah.
It said water bottle, and I had cups and water bottles in place. And I kept a bunch of cups with different amounts of and then I tried to do the model and it came out of water bottle.
What do you think that was the case?
Most likely because I don't have enough examples of the groups. I don't have enough. That's my
It's interesting theory inside there. We'll actually explore more about that and see how it goes.
and the point is that these training things are very dependent on how you train them and how many images you have in your grounds. So that's why.
The architecture as well could have some cost to it too. That's cool. Thank you guys for sharing that, by the way. Okay, well, you have the paper, so we'll just throw it to the next person and write from that. Yeah, so, I mean, fundamentally, what we're really just trying to get at is we'll talk about what actually happens with the training, but, you know, data really is not just an AI, right? It kind of fundamentally goes to this idea of garbage in, garbage out. Not to say that the pictures you guys have taken is garbage, okay? But I'm just saying that, like, basically, it's as limited to the model prediction to what you have basically captured inside there. And we're basically going to see some examples of why that is the case. So I'm going to skip to how the machines learn, and we're just going to do some fundamental exercise for this. So we talked about data, training, and models, and now what we're going to talk about is more of the training aspect of it now, which is where we talk about the technicalities. So we're going to do a little activity called the describer drawer game. How the game works is basically you guys are going to be working in pairs. And I really recommend that you guys work with somebody that you don't know. You know, you can get to introduce each other and get to know each other more. But basically, you're going to work in pairs, and there's going to be two roles. There's going to be the describer, and then there's going to be the drawer. And I'm a teacher. What I'm going to do is I'm going to be drawing a picture right here, and the person that is the describer is the only person that can actually come up and basically see the drawing. Then they come back to their drawer and basically give instructions on how to recreate it. And your hands must be behind your back at all times. Just verbal instructions. Go ahead. Yeah. So, yeah, basically, so find your pairs right now. Find the people you're going to work with. You guys have 3 pairs? Yeah, ready. Subscribers, you guys can come right now. And you can go back to your. Go back and work with me. You can always shift it.
I'm sorry.
You can say that. Anything, but just don't use your hands.
Oh yeah, get a photo. You gotta get the medium shot.
I'll try to get a little closer so you guys don't have to go.
Inside the square.
All right. Good. How about the people in the back? Did you guys get this right here? Hold on. Down as much as you want.
No, go to the right of the circle. To the right inside of the circle.
Inside the
On the edge, that's the other edge, that edge, and then and draw into the circle. Yes.
Oh, just different angles. Okay, I got you. All right, that's enough. You guys want to network bit. Did you guys get this? More or less? Names after the drawing. Hey, really? The hardest person.
You win. Yeah.
You were the hardest.
You're the hardest person. James, can you check? Yeah. Do you guys want to do one more? No. Alright. So real quick. You guys
You got it? Good? Hi.
paper, by the way. It's got the paper down.
We have an eraser. I bet you. Well, and then you got
Oh, the position was like, where do I place it at? Yes. Okay. Okay. I was always curious about this team. You guys were always like art council in the back.
We're serious.
Did you? Yeah, I think so. Did you and your partners use any strategies to help recreate the drawings, or you guys? Yeah. You guys use the strategy. What strategies did you guys use to make it easier?
We're trying to anticipate like what lines were connected and like shared amongst the shapes.
Okay.
That's how it's
It looks like you can throw it to one more person and answer the last question. All right. So what would you do differently next time to communicate more clearly? Or actually, I think y'all's team did pretty well.
I think that when it was watching like me personally, right? And I know that our previous it was just like putting myself in all the groups. I was dealing with myself in describing stuff. Thinking that there was just language, right? But before we have said a lot of things that was straightforward.
You don't know what angles that he might have been.
Yeah, I was just going with another. So,
Like full and circle.
well, I was trying to use full as a reference, thinking that I could make, I can use shapes, right? And
That makes sense.
That's how I was doing myself, describing things the way that I always should have.
That makes sense. Yeah, the perspective is definitely different from both sides. That's good. Thank you for sharing that insight. Yeah, I mean, I think you guys kind of really did feel for what I'm trying to get out of this, but just basically this idea of step-by-step thinking, where we basically just, for you guys have to give very step-by-step instruction in order to create the shape. Draw a square, draw a circle in the middle, and you guys did a pretty strategic style to recreate that. So, this is essentially what we call an algorithm, which is basically just a step-by-step instruction to complete a task. It can not just be technical, it can just be anything, right? As long as you can break down the steps and have it being solved, that is an algorithm. And so, the thing about machines is that unlike humans, machines don't understand things on their own. They basically need algorithms in order to basically understand what needs to get done from the human side. And so my question, or one of the things that I'm quite curious about, is what if we could build this ultimate algorithm of learning? So I'm going to give you guys a little exercise where basically I'm going to show you an image, and you're just going to tell me whether or not you think it goes to class A or to class B. I'm not going to give you any rules. You guys just decide that among yourself, okay? And it's okay to shut up the answer, but I want you guys to really think about your thought process as you're basically determining which one goes to which class. Okay? So, you guys ready? Level 1. Does this go to group A or group B? A. Okay? A. Group A or group B? B. A. Oh, okay. Group A. Group A or B? B. Oh, okay. Okay. What's this one? B. How does this one mind really incredible, right? The fact that I didn't give you guys any rules, but even when you guys were looking at all the different examples, you were able to distinguish when I went to group A and went to group B when I didn't give you any rules. I'm curious to know, what was y'all's thought process of deciding which groups to belong to when no rules were actually involved? Oh yeah, what's up? The parts I was changing, like different types of features, right? Okay. Yeah, what's up?
Yeah, just whatever the most noticeable difference was.
Noticeable difference right there. That's good. And so basically, I kind of want to talk about I mean, obviously your grades are more complex than this, but basic human learning algorithm that we kind of did was something like this. You took a guess, right? You didn't know what you were looking at, but eventually you compared your answer with the actual answer, where you basically measured that error, and then you basically adjusted your guess and you kept repeating that cycle essentially. And so the thing about this is, you took a guess, you were 50% sure it was group A or it was group B, so you had a confidence level to that. And eventually, once you made that guess, you measured your error. So for example, if you guys were actually saying oh, I'm 80% sure that's group A, and it turns out it's actually group B, you'll find that you actually need to adjust your strategy a lot more, right? So there's different levels of confidence. The higher the confidence you're wrong, the higher the adjustment. The lower you actually get things wrong, the lower the adjustments. And then you basically improve your guess. So like what you mentioned, you start to focus on different types of features that really help you get closer to that right answer. You keep repeating that cycle where you essentially take a guess, you measure your error, and then you basically improve your next guess to the next one by adjusting something. And then eventually, you'll be able to, oops, not that one. Over time, you'll be able to build your own rules based on what you essentially learned. And so I don't want to simplify it to this, but you can kind of almost think of this as a math equation, right? The way of how humans work is that we can think of it like this. When we're looking at that picture, we were basically focusing on specific features, right? We were looking at colors, backgrounds, positions, and when you saw that first photo, you're like, oh, I don't really know which feature I should be focusing on. And you're going to see that each of these individual features has the importance level connected to it. So eventually on level 1, you found out that eventually with going all through the data, the background positions were irrelevant and the color was the main thing to focus on. And then at level 2, the color, the color and the position was irrelevant, so you focused on the background. And at level 3, the color and the background were irrelevant, so you focused on the position. But you'll notice that you were adjusting that level of importance as you were looking at multiple data. And so the thing about this is we can actually simulate this learning algorithm machines by giving them many examples so they can find patterns and improve their guesses too. However, there is a big difference, and is that the thing about machines is that the difference of it is that humans are able to find patterns and features like colors and backgrounds. So whatever you guys think, this might be like a tomato or a cherry or an apple, for example. But the thing about it is you guys are focusing on the colors and the backgrounds. As for this computer, it just can't see anything. It's only when we start to add numbers to these systems and correlate the numbers to these colors that we actually start to have the computer able to process that type of information. And so the way our process or a machine process information is almost like this, right? Basically, we have our data right here, and we essentially convert it to some sort of number, and essentially we have the numbers in position that we input to the model. Because the model can only calculate and process information, numbers. And so we can actually decide to add more data. So let's say we decide to add a few more happy faces and some sad faces as well too. We put each image as represented as numbers. And then those are each little tiny data that we can input to the model, and we're going to do some calculations to try to find patterns in those images. So once the model has received all the data, this is where the training process actually happens. And so if you guys remember clearly in the human learning process, we basically took a guess, we measured the error, we adjusted our guess, and we kept repeating that process. Well, very similarly, in machine learning algorithms, we basically have a very similar concept as well too, which is taking a guess is something called forward pass. Whenever you're measuring the error, you use something called loss function. And whenever you're adjusting your guess, you're using something called optimization. And then you have this thing called epoch, which is just this repetition of humming around as you go through that data set. And so humans, right, we basically look at things by features. And we're like, okay, which feature is most important at deciding the answer, right? Is it color? Is it the background? Is it the position, and so on. And it has a little mental equation of which one we should be focusing on. But with machines, what they do, once remember they have all the numbers, or all the numbers of the pixels, right? We basically adjust the importance for each of those different types of pixels. So very similar to how we have features, now we're basically focusing on each features or each pixels and basically assigning it something called a weight. So weight is the same thing as importance inside there. And so what we're really trying to do is we're trying to solve an equation where we're adjusting that weight to basically see how it correlates with input to the output results. So, for example, right? Okay, so I know this is going to get a little bit technical inside here. I'm just going to try to go through it pretty quick. But you can see over here that I just want you guys to focus on the middle part, right? Basically what happens with word, or what a word pass does, is that it just takes all this number, and it basically does a multiplication of each of the pixels with its weights, does some sort of calculation, goes through some sort of softmax to create some sort of probability, and you can see we have a confidence level of, okay, we're 70% sure it's class A, or we're 30% sure it's class B inside here. Then we have our loss function inside here. So once it makes that predicted guess, we basically compare it with the actual answer, which goes into something called a loss function. And what that loss function does is it literally measures objectively how far the predicted answer is from the actual answer, and it returns us a loss score. And then what we do with that loss score is we just take that same equation that we have over here, and we're just essentially adjusting that weight to see which of those pixels is most important at fitting the outcome of it. I know that's a lot of information to take in, but what I'm trying to get at, right, is like for the humans, right, we were adjusting the weights of which feature was most important. And now, basically, with machine learning, what we're trying to do is we're basically also adjusting the importance of each of those different types of pixels to see what leads to the input to the output. So eventually, this is kind of like how the whole cycle kind of works. I know it's kind of oversimplified, but over here you basically have your equation. You go to your predicted answer, you find the actual answer. Goes through a loss function, which outputs a loss score. And basically, what that loss score does is adjust that equation of which of those pixels is most important to coming up with the actual answer. And then the epoch is just the basic amount of times that you repeat the training data. So if you have 1,000 images and you train for 3 epochs, the model will see all 1,000 images 3 times. So I know there's a lot to take in, but the thing that I want you guys to understand about this is that when we say train model, really all we're doing at the end of the day is just working with a big mathematical function. We're just adjusting some weights, just like our brain is adjusting which type of focus or which type of features we should essentially focus on. So this is kind of one of the reasons why everything in the image really matters to a computer, right? For a lot of us, right, if we saw this, like what is this right here for you guys? That's a cup, right? And what is this? But you can see, this is the table, someone say table. Anyway, but you can see over here that once it actually gives picture inside here, it classifies this thing as a cup. And the main reason for that is because with these machine learning models, they look at every single pixel and they just convert to numbers to basically coming out the output. So it decides that this thing is a cup, right? So if your data has just a bunch of cups with white backgrounds and spoons with brown backgrounds, and you decide to use spoon with white backgrounds, it's going to most likely call it a cup because it's only looking at the backgrounds. Right. Okay. So really what I'm trying to get at is it's just not magic, right? I just kind of wanted to kind of take that magic away from it because at the end of the day, its adaptiveness really comes from the algorithms that we've written by humans to simulate that learning. And this autonomous behavior just comes from feeding it tons of data from humans to the point that it's able to create its own rules and make its decisions essentially. Right? So the human is very involved in the process, right? It's just really trying to solve one big equation. So this ultimately leads us to machines unfair, and I'm just going to skip this because I don't think we have much time. We're going to skip all of this right here. I think I can just skip all of this right here. Yeah. So basically, I'm just going to go straight to the point that the reason we talked about this is actually a bias data. And bias data is like whenever you have data that doesn't fully represent the population. So there was a game that I want you guys to think, but I don't think we have a lot of time for it. But right here, basically, there's some students that will only select red apples and only green pears. And you can imagine that, apples can sometimes be green and pears can sometimes also be red as well too. And what that results into is something called algorithmic bias. When the algorithm basically makes incorrect or unfair predictions due to biases in the data that it looks And so, for example, for bias data for humans, sometimes, this is a real thing, right? We sometimes have data sets where it has a lot more lighter skinned folks. And so sometimes in the past, whenever it was darker skinned folks, it was sometimes considered as non-human. And this is actually a real thing that happens, because when we look into, these incorrect mistakes, like our gel systems, right? What we find is that US criminal justice systems use something called the compass algorithm, which it finds that it kind of just looks at the people's faces, and it actually classifies black defendants twice as likely to be more of a higher risk, even though the crime rates are actually a lot more lower. So these things do happen, right? I think as you kind of mentioned, the problem is that these things can really be helpful to us to help augment our decisions, but if we kind of make these decisions too seriously, we believe it too much. It can lead to these really misjudgments and harmful ways for a lot of humans we work with. So, I guess I'll just go for you guys. I'll just do one last reflection. But my question to you guys is, how do you guys think we can reduce the negative impacts of algorithmic bias in AI systems? I just blew a bunch of information to you guys. So. Thanks for sharing that. Sometimes people just, even though we have all this data, right, it's more about who allows that data to flow.
But does it go back to what you were saying about the math? How much do you think that the information that is written text, aside from the actual math, numbers, 1, 2, showing 3 how is that any different? How do you separate the two? Even though one has to run on the other, obviously people's lives are involved. It's not about those specific numbers being used in order. It's more about how the information is being captured, which is it's overlap. Right. So how do you deal with the overlap? That's what I'm asking. In the relationships there.
Yeah, I think one of the things that I try to get at is that it does kind of when it comes to the data that you feed to it, but I kind of want to say that these machines are really just calculators with numbers. So whatever we feed to it, it's just going to operate whatever we have given it. So it's you can't really separate that numbers. It's just more about computation. Yeah.
My answer to that is bring the humans back in the loop.
Bring the humans back into the loop. Good answer. Yeah.
Yeah, we like the reCAPTCHA. That's reCAPTCHA. We have to identify.
Yes.
It's actually doing work for Google or something like that. You make recommendations, right? Because a lot of that data is fed back into, I think they used to do text expectation. So a lot of those old text images were actually from archives and stuff like that. And then when you click on the reCAPTCHA and type in the letters, it goes back to feeding it into the what's called.
Yeah.
Put something in cards too.
It's like a full documentation. All of that.
Yeah, the archive.
Yeah.
Or digital characters. And then now they have stuff
Yeah.
Humans are basically work for free.
Yeah, I actually learned about that too, and I was like, I didn't realize that how involved we were. I thought it was folks were just testing on that robot.
But then it also means human nature too, right? When you get rid of the sheep bias, then you're using human bias instead.
Well, I think it's always going to be human bias at the end of the day, so yeah, makes sense. Yeah, thanks for sharing that.
I think this kind of put a lot of what you said, but going going back, I think the biggest problem with the system that was being used, and it was like misidentifying high risk. I think the biggest issue in that case is the people setting up the system in the first place. The system's doing its best with the data it has, and yes, we can give it better data, but really, at the end of the day, should you be trying to identify risk factor based off someone's face? So it's a matter of you need to decide when an AI model is even the right choice to make in the first place, in addition to feeding it good data and trying to get rid of copy devices.
Bring the human back into work.
Bring the human back to the loop. By fighting stoplights and Google and something. Yeah. Yeah.
Well, just adding into it, right? I think it's just this conception that this is really not AI, this is just a part of the AI. This is pretty much machine learning. I mean, this is just fine. This is to make cool AI.
Yes.
We're missing logic, meaning, which at this point we don't have whatever it is in order to choose what we do. So at that point, in order to produce their impacts, it's just like we're leveraging machine learning as an AI, which is not. And to do things that we're expecting to do as a regular AI, which is not. So I think the misconception of AI as it is just full-fledged. This isn't there. It's just like, grasp of it, right? So thinking that it's going to do that the way you think it is just a misconception.
That makes sense. The intention is not really going to what humans do. It's just that makes sense. Thank you guys for
Yeah, I'm just going to say that one other thing on this too. Similar, it's also about using the right tool for the right job.
right.
Is AI best to do, helping us get groceries or risk assessment, right? Like it's something where we have to be the governors of that data and we're going to use it as opposed to just kind of blindly saying, okay, here's a model that's going to say yes and no and what you say. So I think that a lot of the algorithmic bias comes not just from the data quality and what people choose to teach it, it's also kind of the gentleman's point, should that be an AI job or should that help?
Should it be the decision maker or should it be the organization? That's great. Great. Thank you guys for sharing your points about it. I appreciate it. That was actually a good discussion. Wait, I have this. All right. Well, anyway, I'm going to kind of skip through that because I think we had a good party discussion about that. I think I could just kind of skip this part aside here. But I think it kind of does a good job kind of wrapping what we kind of discussed about this. I think this is just more of my opinion on it, right? Because, one of the big questions we talk about is like, what exactly does it mean to be human? What distinguishes a human from an actual AI model that we've seen? And really what we see at the end of the day is that these AI models are really just pattern. We talked about how really they're just equations that are basically doing a bunch of calculations, crunching numbers, it's soulless, right? There's not really purpose or care to it. While for humans, we actually have that purpose. And we actually care about the risk that we're actually having people involved in decisions making. So I just want you guys to just think about these tools as more of augmentation rather than decision makers, especially when you hit those more high risk kind of situations. So anyway, that's the end of class. I appreciate it.